Hello, let me introduce Touching the Moon, a project from a team composed of researchers from the Arts et Métiers Institute of Technology, the European Space Agency, but also many other academic institutions across Europe. This work aims to explore the potential application of virtual reality in association with passive haptic props to support the preparation of future crewed mission to the Moon. More than half a century after the last Apollo mission, humankind is going back to the Moon. NASA and its international partners have already taken critical steps for the Artemis program, which aims at landing a crew on the lunar surface by the end of this decade. Astronauts landing on the Moon will likely have to embark on so-called extravehicular activities, or EVA, also known as spacewalks, to gather terrain samples, deploy science equipment, or even perform infrastructure maintenance operations. These critical activities are thoroughly prepared as concepts of operations, also called CONOPS. The traditional method for testing and validating CONOPS involves complex and costly real-world deployments. Our work proposes a shift towards virtual evaluations using immersive technologies, offering a more resource-efficient approach. CONOPS are usually designed, instantiated, and then tried out in terrestrial testbeds that are chosen for their similarities with the lunar landscape. However, these testbeds usually lack critical features of the Moon, like the reduced gravity or the unique lighting conditions, thereby impairing the fidelity of such studies in potentially important ways. Moreover, analog field studies are also known for incurring substantial costs or complex logistic. Immersive simulations utilizing virtual reality technologies are well positioned to overcome such limitations. By virtue of interactive simulations, virtual reality can audio-visually convey any conceivable lunar scenario within a digitally recreated environment. However, virtual reality has also been criticized for lacking adequate haptic feedback. Indeed, improving the fidelity of VR simulations by integrating passive or active haptic modalities constitutes a major recurring theme in human-computer interaction research. Similar to analog test beds, virtual reality thus suffers from its own drawbacks, impairing the fidelity of the user's experience. The fidelity of virtual reality simulations can be leveraged by acting on two factors: presence, which refers to the user's sense of being there in the virtual environment, and embodiment, which refers to the degree of appropriation users have with their virtual bodies. These factors are commonly recognized as VR qualia. Existing literature has shown that haptic modalities can positively influence VR qualia, including presence and embodiment. Building upon this research, we have sought to assess the potential impact of passive haptic modalities on VR qualia within the context of simulated lunar CONOPS studies. Evaluating the fidelity of a VR simulated lunar operation is challenging due to the limited number of pre-existing manned missions to the Moon. Fortunately, the Apollo program provides us with a goldmine of data concerning operational activities. All procedures were meticulously planned, executed, and documented through debriefing sessions with the returning crews. For our project, the Apollo 12 mission seemed well suited as a case study, due to a particularly rich dataset of crew feedback. During this mission, the surface team, composed of the astronauts Pete Conrad and Alan Bean, was tasked to deploy the Apollo Lunar Scientific Experiment Package, ALSEP, on the surface of the Moon, consisting of several scientific instruments. Specifically, the ALSEP deployment CONOPS entailed retrieving 2 packages from the lander, assembling them into a barbell for transportation, transporting it to a deployment site nearly 90 meters away from the lander, and finally deploying the different instruments. 2 features of this operational concept attracted criticism from the Apollo 12 crew. The first one is the ALSEP barbell, whose mass resulted in a weight equivalent to 27 kilograms on the Moon. Carrying this weight in the bulky suit was physically challenging for the astronauts. The whole package was also unbalanced, which caused the bar to tilt during the transport. The second feature that attracted criticism were the bulky EVA gloves worn by the astronaut. Their thickness and the fact they were pressurized turned simple grabbing task into a nightmare for the astronauts. For our experiment, we thus replicated part of the barbell assembly and traversed tasks in a VR setup. The scenario took place in a virtual lunar environment recreated based on topographic data from the actual Apollo 12 landing site, next to Surveyor 3 crater. Ephemerides provided by the NASA Jet Propulsion Lab, coupled with the power of the Unreal Engine, allowed us to faithfully recreate the lighting condition as they were at the mid-time of the Apollo 12 mission activity. The participants were embodied in a virtual representation of the Apollo suit gloves, as well as in a virtual helmet reproducing the restricted field of view of an actual suit. Complementary to their virtual representations, both the barbell and astronaut gloves were also physically available through low-fidelity passive haptic mock-ups. Additionally, during their VR experience, participants were tasked to manipulate several virtual tools and objects and eventually shift to the barbell physical mock-up. To enable these interactions, we designed a unique pair of controllers that are able to seamlessly interface with both the barbell and gloves. This design, in turn, reduced variability across the experimental conditions as the controllers were used in all conditions with and without haptic props. Talking about the experimental design, we followed a mixed methods approach. Wearing gloves was investigated as a within-subjects variable with two conditions: wearing or not the gloves during the VR experience. Using a barbell mock-up was investigated as a between-subjects variable with two conditions: using or not the physical mock-up of the barbell. This design resulted in two independent groups of participants. We recruited 24 experts in the field of human space exploration. Their profiles ranged from engineering, management, or medicine to astronaut training. We also recruited 3 astronauts, 2 of them with mission experience, totaling 547 days in space, along with 14 hours of EVA time around the International Space Station. Using appropriate questionnaires, we measured participants' sense of embodiment with regards to their virtual hand representations, presence in the virtual space, system usability of the whole setup, and finally the task load for both the object grabbing and carrying operations. We also gathered qualitative feedback from our participants, allowing for a direct comparison to the Apollo 12 crew's own feedback. As results, the distinct setups displayed similar and acceptable levels of usability. But wearing actual gloves significantly increased embodiment through the body ownership dimension, but also the sense of presence through the dimensions of perceived realness and general presence. Moreover, wearing gloves while manipulating the barbell mock-up significantly increased the perceived realness. All in all, the configurations with passive haptic props were found to contribute towards making our participants feel like an actual astronaut there on the moon. This trend was further highlighted by participants' qualitative feedback. Participants reported that using physical gloves offered a more natural user experience compared to traditional VR controllers. The study likewise revealed a notable synergy between the gloves and the barbell physical mock-up. The importance of feeling the weight of virtual objects and the difficulty entailed in their manipulation while wearing gloves was frequently emphasized. Overall, the physical exertion induced by this interface thus proved to significantly enhance both a sense of presence and embodiment, as well as the perceived realism of the simulation. In terms of perceived workload, as expected, wearing gloves negatively affected both the object-grabbing task and barbell-carrying task. This also means that even without carrying the mock-up, holding the grip on the controllers while wearing the gloves was rated significantly more difficult than without gloves. Finally, as anticipated, using the barbell mock-up increased the physical demand dimension, but not on the general workload score. It was expected to witness elevated workload scores with the passive haptic props, which made the scenario more difficult and therefore closer to what the Apollo 12 crew experienced. This is further reinforced by the qualitative insights. The use of haptic interfaces played a significant role in shaping participants' reflections, particularly in tasks involving object manipulation. The physical strain induced by the gloves and physical mock-up prompted several participants to complain of hand fatigue. Similarly, many participants reported the rubbery gloves made it difficult to achieve a secure grip when carrying objects, which strongly aligns with the Apollo 12 crew feedback. Overall, our findings indicate that haptic interfaces can play a crucial role in aligning virtual experiences with real-world scenarios, thereby enhancing the validity of user reflections. All in all, our work demonstrates the benefits of two different passive haptic modalities for VR evaluations of prospective concepts of operations. The results suggest that increasing the fidelity of the simulation through elevating embodiment and presence with passive haptic props contribute to a greater validity of VR-based ConOps assessment.